Hi guys, today we're going to talk more about the heat stuff and thermodynamics and physics, and yeah. First thing we're going to talk about is thermal equilibrium. What is thermal equilibrium? Well, thermal equilibrium is when two objects of different temperatures are placed in contact, and then the heat will flow from the hotter object to the colder object, and that's because of the second law of thermodynamics, which states that heat always moves from the hot object to the cold object. And when they reach the same temperature, when the hot object and the cold object reach the same temperature, they're in thermal equilibrium. So thermal equilibrium is when two objects have the same temperature. So let's do a quick problem with this. Let's say that 3 kilograms of gold, this is with gold, so there's gold, and there are 3 kilograms of gold at a temperature of 20 degrees Celsius. It's placed into contact with copper. With 1 kilogram of copper. At a temperature of 80 degrees Celsius. So copper here is the hotter object. So the question here, and the C is, and the specific heat of gold is 130 joules per kilogram times degrees Celsius, and C just equals 390. So I'm going to repeat the question again. So 3 kilograms of gold are at a temperature of 20 degrees Celsius are placed in contact with 1 kilogram of copper, which is 80 degrees Celsius. And the specific heat of gold is 130 joules over kilogram times degrees Celsius, while the specific heat of copper is 390. Sorry, you can't really see a 9 there. Kilogram times joules over kilogram times degrees Celsius. At what temperature do the substances reach thermal equilibrium? Well, let's do this problem. So let's erase all this stuff. So we already know what's going on. Well, we're gonna need 2Q equals MC delta T equations for this type of problem, since there's gold and there's copper. So the first one is Q equals mCg delta Gg. Sorry, delta Tg. So this is the heat gained by the gold, because the gold is at a colder temperature than the copper. And then the second equation that we're going to use is Q equals mC C change in Tc. And this one tells us how much heat copper will lose. Well, if we set these two equations together, we're gonna get something like oh, sorry, I forgot to put the G right here and the C right there. So we get something like mgCg. So we're setting these together because we know that the heat lost by one object will be gained by the other object. So the heat gained by the cold will be equal to the heat lost by the copper equals mccc change in Tc. And once we plug in all our known variables, well, we already know most of them. The specific heat of, we get something like 130 change in times 3 change in Tg is equal to 390 change in Tc. Well, now we can cancel out the 390 on both sides, and we get delta Tg is equal to delta Tc. Because these two are the same, it tells us the temperature change of both of these objects is the same. So what does that mean? So let's say that gold goes up by 2 degrees Celsius. That means that copper will also decrease by 2 degrees Celsius. One gained by the other will be equal to the loss by another in heat. Well, what does it mean in terms of this problem? On this problem, you can just take the average of the two. And once you take the average, you'll get of the two initial temperatures, you'll get 50. And 50 makes sense because that's just saying as copper loses 30 degrees Celsius, then the gold will gain 30 degrees Celsius, making these two at a thermal equilibrium at a temperature of 50 degrees Celsius. So thank you guys for watching, and please tune in for the next video on phase changes. I'm out.